You could share your screen.
Okay.
Yep, go ahead.
Great. Okay. So, good morning, Professor. Thank you for thank you for having me this morning. Thank you for making the time. Let's see. So this is the starting point. Basically, it all, of course, started with the summer program, the Data for Impact program, where we were able to calibrate the Black-Scholes model using an ANN. And the goal from that was to kind of calibrate like a starting model, that one that was simple enough for people who didn't really have that much experience to understand. And we were able to do that. We did obtain an output, which we presented at the final presentations. The issue there was that we just needed some parametric adjustment to actually reflect like the necessary outcome. So from that we learned a lot, and what we gained from that for this semester was that those kinds of like specific like calibration techniques, or like what kind of parameters we need to adjust and how we would do that, as opposed to like manual calibration. So we chose a new model like after a few like team meetings, and the one that we chose was the Hull-White, which is a one-factor model. So through like the team meetings that we've had, like maybe 1 to 2 times a week, we assigned like different team members like different tasks to do with the model. So for example, Brianna was doing the literature review, and me and Keith were doing the actual coding part. And so the ultimate goal really was to calibrate the model, like to predict interest treasury rates as per Harry-M's instructions. So these were a few of the challenges that we had to face like this semester at least. So for me and Keith, mainly the coding team, it was the fact that we had to learn like Python from scratch, like to achieve those calibration goals. The ML part of it as well was a factor. The second challenge, I think, which was kind of applicable to everyone across the board, was like the linear algebra, kind of at a higher level than you would get in maybe like Math 250 here. So that had quite a steep learning curve, so that we were watching videos, and we have like a little repository of resources that we were using to understand that. And so that was, you know, gradually understanding the true mechanisms behind the factor models. So the other thing is more of like a qualitative issue, where it was like having to push yourself, right? Like having to not really depend on like a specific professor or like a specific like figurehead to like always prompt you and like always like ask you of like certain goals to meet. And I mean, in a opposition, it's like you kind of had to pave your own path and like understand what goals you had, like create your own goals, and then like actually work to meet them yourself. So that was also a challenge, but it kind of, I think, benefited in the way that it truly exposed us to like having to independently learn, which wasn't like something that a lot of us were exposed to before. So this is kind of a timeline of the semester, like how everything went. From the first team meeting was when we truly like started delegating different tasks to different members. So that I feel like that was really helpful, because it gave like structure to something that seemed like very kind of all over the place, especially since we had team members leaving from the summer. And then the CI&Q meetings, like, so that having like a specific deadline like in the middle of the week or so actually gave like a good incentive to our team members to like have something to show for CI&Q, of course. And then the sponsor meetings, of course, like that's where like the actual kind of learning happened, I suppose, since we had like access to Harry and like his like we could ask questions about what he thought was right to do, and which, I mean, it's like a fairly simple like direction that he gave. So that was helpful, of course. And then meeting with professors like Professor Bowen, he provided clarification on like some of the linear algebra, like stochastic calc side of things, and also some ML techniques. And he kind of emphasized to like start slowly, like, or like start a little bit like back from what we were trying to do, like jump immediately into the ANN or like jump immediately into ML. Was his advice was just to start with like manual calibration. So that's what we did. And yeah, this final presentation, just like reporting on the timeline of the progress made and like what kind of efforts we put in over the semester. And so this is the model that we've chosen. It's the Hull White model. It's a factor model, which it's basically a mathematical model, which is used to like approximate like treasury bond rates. Oh, well, from what Harry wanted us to do. It's also used for like interest rates, of course. And so that's like through running like various statistical techniques, like over a different bunch of factors or variables, which are believed to affect the independent variable being approximated. And so the models are called factor models because the outcome like depends on one or many of the factors included in the model. So this is a single factor model. So it involves using only one independent variable to approximate the dependent. And that's the equation right there. Time dependent variables, and then there's the mean reversion rate, which is it's like a theory used where it suggests that the asset price or like the volatility will eventually return to the base level, or like that the long run mean will eventually return to the average level of like the entire data set that we're using.
Just let
So
me stop you for a second. This concept of mean reversion, you haven't seen that in your curriculum yet.
no, not at all.
Okay.
We had to like independent. That's what I'm talking about with like the independent research.
Yeah.
So yeah, those kinds of things, especially because in my major, like in economics, like you don't really learn about that stuff anyway. And in Keith's, he is finance major, but it's I think it's a little more advanced than he would be learning in his courses as well. So yeah. And then Brownian motion, that's more the random motion, stochastic concepts. So yeah, standard deviation, the course in the R is the short-term interest rate. So it's, I mean, it's more or less like straightforward. Like it was just enough for our team to be able to understand, but also like slightly more complex compared to the Black-Scholes, that it actually did give us a bit of a challenge as well. So I think that was a good choice. So this is our actual like manual calibration code right there. Like I use packages like Quantlib was the main one. And then it was just a case of like changing the mean reversion and the sigma, just kind of by trial and error really was the advice that Professor Bowen gave. And the output that we got was this, which is like, I mean, fairly similar to, I mean, what we wanted to get. So this is the actual curve, and this is what we got. So there definitely was some level of like clarity that was achieved with Professor Bowen, like the meeting with Professor Bowen, because it's one thing to like go out and like onto the internet and just like search randomly for things that you don't even know about, but that provided some good direction, and we understood what we were looking for in the first place. So from that point on in the semester, we were able to kind of find our footing a bit more. So these are some other ML techniques that I suppose in future plans I'm kind of thinking of implementing right here. So I can show you. So yeah, so like the boosting techniques and like the that kind of stuff, like with the, yeah, like the AdaBoost regresses, the random forest and the yeah, it's mostly from like sklearn. These are things that I actually learned from my econometric software class, which is both an undergrad and a grad class. So I was able to like see actual concepts that we could apply to financial equation in one of my classes. So that proved to be really interesting. That was more towards the end of the semester. So I think this is more of like a future thing that we would consider for the project. But yeah, that's my presentation. Thank you, President.